Good morning, everybody, and welcome to the Southeast Drought Webinar, Conditions, Impact, Resources, and Outlooks. My name is Elliot Wickham. I am the Southeast Drought Early Warning Coordinator for NOAA's National Integrated Drought Information System, or NIDIS. So a DEWS, or a Drought Early Warning System, is a part, or a regional DEWS exists to help facilitate and deal with regional drought needs for the nation, but specifically for the Southeast here, for 6 states: Tennessee, Alabama, Georgia, Florida, South Carolina, North Carolina. We provide forums for sharing information and experiencing with managing drought, provides information and delivers information through newsletters, drought status updates, webinars, and drought.gov. And we also document the gaps and needs and opportunities identified by the network of partners that we have in the region. Today we have a webinar. Obviously, that's what we're here for, talking about the conditions and the drought in the Southeast. You can sign up for the webinar series that we have with the QR code that is in the top center of the page. And you can also see the latest drought status update for the region on the right side there of the slide. Those will be provided at the end as well. Today, I know we usually have a webinar series every month where we talk about the conditions for climate, water, and ag, as well as a special presentation. But today we're going to be pulling many of the partners across the region to talk about conditions across sectors in each state and where we're going with conditions going forward. So we have a pretty packed agenda. Here's the lineup of what we'll be covering, and I will pass it over to Chris with the Southeast Regional Climate Center here to give the climate update, or where we're at with this drought.
All right, thanks, Elliot. Thank you all so much for being here. So what I'd like to do over the next few minutes is provide a brief overview of the current drought across the Southeast DEWS region, where conditions stand right now, how we got here, and how this drought compares, at least so far, to some of the more significant droughts we've experienced across the region over both the recent and longer-term historical record. Okay, next slide. All right, so first, where are we right now? So this map shows the latest U.S. drought monitor from last Tuesday. And while we have seen some slight improvement in at least a few areas, especially across parts of Alabama and Tennessee, the broader picture remains pretty remarkable. At this point, the entire Southeast DEWS region is still experiencing at least some level of dryness or drought. Over 99.5% of the region is in at least moderate or D1 drought. More than 90% is in severe drought or worse. Over half the region is in extreme drought, and about 10% of the region is currently in exceptional drought. That's the highest drought category, and that extends from the Florida Panhandle through southern Georgia and into parts of southeastern South Carolina. As a quick reminder, these drought categories are based on how unusual conditions are compared to the historical record. Once we get into categories like D3 and D4, we're talking about conditions that occur less than 5% of the time historically. And in terms of impacts, those become more noticeable this time of year. We're seeing increasing stress on agriculture and growing concerns about water supply in some areas. Across several states, we've also seen burn bans and elevated fire danger over the past couple of months as these dry conditions have intensified. Okay, next slide. All right, so how did we get here? Well, what's interesting about this drought is that it has developed relatively slowly over many months. Conditions were actually in pretty good shape last summer following a very wet spring and early summer across much of the region. In fact, rewind to last May, a year ago, and we had actually recorded the second wettest May on record for the Southeast region. But that changed pretty quickly as we moved into September and October. During that period, dryness and drought expanded rapidly across the region. And by the end of September, about 80% of the region was experiencing at least some level of dryness or drought. That's remarkable given that 70% of the region wasn't experiencing any drought or dryness at the beginning of the month. Conditions then generally worsened through the winter and especially into early spring, with severe and extreme drought expanding substantially during March and April, which we'll talk about in more detail here in a minute. We also saw exceptional drought emerge across parts of Florida, Georgia, and the Carolinas, and this marked the first time D4 had been observed in the region in over 2 years. So while this drought didn't develop, I guess, explosively, it has steadily intensified over time and become increasingly widespread. Okay, next slide. So not surprisingly, this drought has been driven largely by significant precipitation deficits that developed beginning in late summer and fall. On the left, we see precipitation departures from normal since September 1st, and much of the region is running deficits of 8 to 16 inches, with some locations even higher than that. For many areas, that means they've received only about half, or in some cases less than half, of their normal precipitation over the past 8.5 months or so. And when we look at how these totals rank historically, the picture becomes even more striking. The map on the right shows that many locations across the Southeast are experiencing one of their top 5 driest such periods on record, with several locations ranking as the driest on record, including parts of Virginia, the Carolinas, and Florida. Okay, next slide. And these deficits remain significant even when we zoom out to the climate division, state, and regional scales. On the left, we see that many climate divisions across the Southeast, especially Georgia, across Georgia, the Florida Panhandle, southern Alabama, and parts of the Carolinas experienced their driest September through April period on record, with these records going back to 1895. On the right, we see the monthly state precipitation rankings since last fall. November especially stands out as an exceptionally dry month region-wide, ranking as the 6th driest November on record for the Southeast as a whole. Several states, including North Carolina, South Carolina, and Georgia, experienced their driest such periods on record during parts of this event. So this isn't just, we're not just talking locally dry, in a few places. This has been a broad regional scale precipitation deficit extending across much of the region. Okay, next slide. However, the precipitation deficits are only part of the story. Over the past couple months, we've also experienced unusually warm conditions across much of the Southeast, and that warmth has really accelerated drought intensification. On the left, we see temperature departures since March 1st, with many locations running 5 degrees or more above average. In some places, daytime maximum temperatures have been as much as 8 degrees above average. And when we look historically, nearly every state in the Southeast Dews region, except Florida, recorded its warmest average maximum temperature on record for the March through April period. So we've not only been dry, we've also been exceptionally warm, and that places additional stress, and has placed additional stress on soils, vegetation, crops, livestock, and water resources. Okay, next slide. And actually, it's this combination of warmth and dryness that really makes this spring especially unusual historically. This figure here compares regional precipitation and temperature for March and April going all the way back to 1895. Years that are warmer plot higher on the graph, and drier years plot further to the left. And so as you can see, 2026 sits all the way in that upper left corner. So in other words, this has been both one of the warmest and one of the driest starts to spring on record across the Southeast. When we combine those rankings together, this year even stands out compared to other major drought years like 1967 and 2012. Most recently, 2012 was about as warm, but not quite as dry, while 1967 was drier, but not nearly as warm. And these unusually hot, dry conditions have substantially increased evaporative demand, and also helped intensify drought conditions over the past several weeks. Okay, next slide. So what caused this pattern that we're in right now? Well, it really comes down to a combination of a few large-scale factors. First, we had, as we all know, we had a fairly quiet hurricane season in 2025. Across much of the region, we had very limited tropical rainfall and impacts across the Southeast. Second, La Nina conditions during the winter helped shift the storm track further north, so that often favors drier than average conditions across the Southeast during the cooler months of the year. And finally, the persistent warmth and high pressure this past spring that we've talked about, or this current spring, continued to suppress rainfall and also increase evaporation rates. So we've essentially had now multiple seasons in a row, going back to fall and then winter, and then here as we begin to wrap up spring, where the atmosphere has really favored dryness across much of the region. Okay, next slide. So to place this drought into a longer historical context, we can look at the Palmer Drought Severity Index, or PDSI. This is a long-term drought metric that incorporates both precipitation and temperature to provide an estimate of overall moisture conditions. Negative values indicate drought, and the more negative the value, the more severe the drought. And what's really useful about this index to start with is that it extends all the way back to 1895. So it allows us to compare modern droughts, including the current one, to events from up to a century ago. So several historical droughts stand out on this graph. You can look at the drought of 1925 to 1926 as one. Also the 2007-2008 drought. Those kind of remain the benchmark droughts in the modern Southeast climate record. Now the current drought has not yet reached the severity of some of these historic events. However, what is notable is that the April 2026 PDSI value is the lowest value for April on record in the Southeast region. So while this drought may not yet rival the absolute worst historical droughts on record, it is extremely unusual for this time of year. Okay, next slide. All right, so here we're looking at drought evolution using the U.S. Drought Monitor. This only goes back to January of 2000. But several major droughts do stand out, ones that we're probably more familiar with and more recent. We have the prolonged drought that actually began to the left of the graph in 1998, but extended to 2002. Of course, the drought of 2007, 2008. We also had a drought in 2011 and 2012. And the most recent significant drought that we had was in 2016 that had major impacts on water supply and wildfire activity. So compared to some of those events, the current drought developed more gradually beginning in late summer and fall and has been slowly intensifying throughout winter and spring. But despite that sort of slower evolution, this drought has become record-breaking in terms of spatial coverage. In April, for the first time in U.S. Drought Monitor history, 100% of the Southeast Dews region was experiencing either dryness or drought. We've also, as you can see there on the slide, we also set regional records for the percentage of the region in moderate drought or worse, severe drought or worse, and extreme drought or worse. Now, exceptional drought coverage, D4 coverage, is still well below what we saw at peak during the 2007-2008 drought. But what makes the current event so remarkable is just how widespread the severe drought, or D2 coverage, has become across the region. Okay, next slide. Okay, and another useful way, because we're really emphasizing the spatial extent here, another useful way to compare droughts is using the Drought Severity and Coverage Index from the Drought Monitor, or DSCI. This metric combines both drought intensity and spatial extent into a single number. So higher values indicate droughts that are either more severe, more widespread, or both. And remarkably, the four highest DSCI values on record for the Southeast Dews region have all occurred just within the past 4 weeks. And what's interesting here, too, is that while the 2007-2008 drought saw much greater coverage of exceptional drought, it was actually less spatially extensive overall than the current drought. And so those DSCI numbers at peak are somewhat lower than what we see now. And that was actually true for many of the other major droughts as well that I'm showing here on the slide. So even though the current drought hasn't produced as much exceptional drought coverage as the drought from 2007-2008, it has become more spatially extensive across the Southeast as a whole. And again, that really highlights, I think, one of the more defining characteristics of this drought, and that is its sheer geographic scale. Okay, next slide. Okay, so as we've mentioned, right, this drought is historically significant in several ways. It's become one of the most spatially extensive droughts, at least in the U.S. Drought Monitor era. It's produced record coverage of moderate through extreme drought categories across the Southeast, and it's occurred during one of the warmest starts to spring on record. At the same time, though, it's important to remember that we're still relatively early in the warm season, as hard as that is to believe. Historically, many of the region's most impactful droughts have intensified during summer and fall. So what happens over the next several months is really going to be critical. And looking ahead, one factor that we're going to continue to watch closely is ENSO. Historically, El Nino winters tend to favor wetter conditions across parts of the Southeast and can sometimes help alleviate drought, while La Nina often favors persistence or worsening drought conditions. Right now, as I'm sure we'll hear about later, the latest outlook suggests a transition towards El Nino conditions later this year, with the potential for a fairly strong event developing and persisting through the upcoming winter. Now, if that forecast verifies, it could increase the chances for wetter conditions and perhaps some drought relief across parts of our region. But of course, there's still a lot of uncertainty in both the timing and strength of that development. And of course, drought recovery, which we're hoping for here, ultimately depends not just on a couple of rainfall events, right, but on sustained precipitation over time. So overall, just to kind of wrap up here, this is still an evolving situation. And it will be important to continue monitoring both the precipitation patterns and the temperature trends as we move through the remainder of the year. So that's all for me, and move on to the next speaker.
All right, well, let's jump right in. I'm Pam Knox from the University of Georgia. I am the director of the Weather Network and an extension climatologist. And let's go ahead to the first slide, which I think is a review of what Chris talked about. And so you can see there the drought monitor without all the fancy boxes in it down at the bottom, again, showing the relatively rapid increase. And I'm not going to spend a lot of time, but I want to remind people that are in the agricultural sector, the drought monitor does not do a good job of talking about agricultural drought because they're looking more at longer term precipitation deficits. And so if you get frustrated because it's really, really dry where you are and the drought monitor is not showing it yet, that's because agriculture is the leading indicator for drought because those plants need water every week. And it takes a while to build up those really big deficits that are used by the drought monitor authors to identify drought. So if you're frustrated at that, it's no wonder. Let's go ahead and jump to the next slide. I broke this down into impacts in fall, winter, and spring, and then a little bit on what we're going to do. There's a lot of words on here. You can go back and look at the recording later if you need to. Generally in fall, as Chris mentioned, it was getting a lot drier a lot quickly. And so the dry conditions caused a lot of problems for pasture growth. A lot of farmers did not get their last cutting of hay. A lot of people had to reduce what they planted as far as winter grains go and forage and things like that. The lack of rain also caused some problems for harvesting in some areas because the ground was so crusty. It was hard to get equipment into the ground. They lost peanuts because it was hard to invert those plants. And also we had a relatively early first frost in mid-November, which is earlier than it is for a lot of years. And so that resulted in an earlier than usual end to the growing season. So unfortunately, some plants, because of the dry conditions, really never reached their peak potential for that. Most of the peanuts were harvested by the end of November, but some cotton was still in the fields into December. And I noticed, I look at Seymour condition monitoring reports, there were nothing was listed in the fall, but CocoRa's also has condition monitoring maps, and they showed a lot of widespread dry conditions. So for those of you who put those in, good job. That is very useful to the drought monitor authors as well as the rest of us that are looking for impacts. If we jump to the next slide, we look at the rainfall accumulations. I just picked the Augusta area because it's sort of in the middle of everything. And you can see the blue year is the wettest year on record, which was 1997-98. The brown is the average increase. It's accumulated precipitation starting September 1st. And you can see in 2025-26, the green line, it was actually lower than the long-term record. And so that just shows how dry it was. And Augusta wasn't even the driest part of the whole region. You see, it did improve a little bit more later in the record, and they're now no longer the lowest on record. That goes now to 2011, 2012, which of course was another drought year, more in central Georgia. But you can go, there's instructions here for getting one of these for your own area if you want to look at that later. So let's go on to the next slide. and look at impacts on agriculture in winter. Of course, a lot of things are dormant then. They were still doing some harvesting in fall. It was dry, so at least you could harvest. So that was good. And over the course of the winter, even though we had a La Nina winter and it was warmer than usual, we still had some really big freezing outbreaks, and especially hit Florida hard, and the fruit crops got way down on the peninsula. David Zierden may talk about that a little bit more, although I think we're going to look more at drought. They had a huge loss from the freezing conditions of almost $3.2 billion. Some of the other impacts that we're seeing over the winter months, with winter wheat emergence was really stalled because of the dry conditions. Pond levels were very low. That was starting to show up in the Seymour reports and the cocoa rods condition monitoring reports. I also got a number of phone calls from blueberry producers in Florida asking about whether or not they could use groundwater for freeze protection, because the groundwater was so low that they were worried they might run out of water. Unfortunately, a lot of the temperatures got so low that I'm not sure that the freeze protection would even have been effective. And so there was quite a big loss of blueberry production in Florida because of the cold weather. The snowfall did provide a little bit of moisture, but snowfall is pretty dry. There's usually not a lot of water content to that, so that didn't really help very much. And the dry soils were really a concern for early corn planting in some of the warmer areas in the southern part of the region. Very little hay or pasture was growing, and so there was really heavy feeding. I talked to a number of people who had to buy hay from well out of state to try to make sure that they were feeding their cattle. A lot of people also had to sell some of their cattle. We go on to the next slide. I like to look at the phenology records just to show sort of what's happening overall as an integrated factor of what's going on. This shows when the first leaf date occurs on the left-hand side and the first bloom date on the right-hand side. You see, we started out pretty warm early in the season, so we got an early jump on first leaf in Florida and along the Gulf Coast, but it stalled out with all those cold outbreaks, and it took a while. And then once everything warmed up, everything just bloomed at once. And so in some odd respects, we had sort of a pinched or a condensed spring from the temperatures that rose just really rapidly right at the end of the season after those cold outbreaks. Now, if we go to the next slide and we look at some of the conditions or some of the impacts of spring conditions on agriculture, as Chris mentioned, it was very warm and very dry in most of the region. That enhanced the drought development a lot. Some people did get early planted corn in while there was still some moisture. And of course, it depends on whether or not you have irrigation. If you have irrigation, then most crops were doing really well. They got a lot of sunshine, so everything was developing ahead of normal. But it probably cost a lot of money to run all that irrigation with diesel fuel. A lot of ponds returned to very low conditions or dried up. Winter grains and pastures continued to be affected by the dry conditions with some poor stands and issues with grain filling. Some of the other things are, if we see a lot of development of wildfires, and I know the person after me is going to be talking about forestry, so you'll hear more about that in a minute. Also, some of the dry and dusty conditions increased diseases and pest pressure on strawberries in the areas where they grow strawberries, as well as sun scald because there was so much sunshine. And so that is something that they really had to watch. We go to the next slide. The current impacts that we're seeing right now, the warm and dry conditions are continuing to enhance drought. We've got some rain. The thunderstorm rain is very spotty, so somebody can get a lot, and the person the next farm over might get almost nothing at all. So the drought monitor can't handle that really high variation rainfall very well. Most places, I did check the ag statistics, are similar to last year in terms of the percent of corn and cotton planted, except Virginia's a little behind, and Alabama and Tennessee are ahead of last year. Planting of peanuts is behind in most areas right now because of the poor conditions of the ground. They don't want to put seed into the ground if it's so dry. And the pasture and range, really not very good either. Continuing to see a lot of comments about that in condition monitoring. The good news is that we are appearing to get into a more typical pattern of frequent rain and thunderstorms, but that's real spotty, and we don't see anything in the near time period that looks like it's going to be a drought buster, which is either a tropical storm, well, we're not in the tropical season yet, or some kind of sustained stationary front that drops long periods of rain across the region. So we don't see any of that coming anytime soon. So I think the drought, unfortunately, is probably here to stay for a little while yet. And if we go on, I think that's my summary slide. So I'm going to leave that and turn it over to the next set of impacts, which I think is forestry.
Yeah, good morning, everyone. My name is Andy Snyder. I'm a predictive services meteorologist based in Atlanta with the U.S. Wildland Fire Service, covering the southern area. On to the next slide. So the southern area does cover the southeast, but includes additional portions of the southeastern and southern United States, from the southern plains to the east coast. We also forecast conditions for Puerto Rico and the U.S. Virgin Islands. I want to stress that the numbers you see here for year-to-date initial attack fires and acreage compared to last year are preliminary for this year. We'll get some more, a better indication of the exact numbers probably by early next year. But for the southern area as a whole, we have seen an increase in the number of wildfires this year. As of last Thursday, 18,000 fires, and then for acreage, well above what we saw last year. Now, I do also want to stress the number of acres we see in the southern area is highly dependent on those southern Great Plains wildfire outbreaks that can easily add hundreds of thousands of acres in a day. But of course, with all the drought we have in the southeast, we did see consistent activity through fall, winter, and spring now, and that has definitely led to some cumulative fatigue. It has been an exhausting month or so across the southeast. On to the next slide. One of the big surprises, I think, for a lot of folks this year is that we were able to accomplish an increase in acreage for prescribed fire. Typically, in a drought year, you may not have as many good burn windows. Fuels are just too dry to burn, safely in the region. But that was not the case this year. We have accomplished well over 3 million acres compared to last year's 2.8 million through the first part of May. We increased the number of burns as well across the region. So even though drought can limit the ability, we did see some well-timed rainfall, and then that basically allowed us to burn in much higher humidity conditions than we would normally be able to. There were some challenges, of course, brought on by the drought, sportier fire behavior than may have been expected. We also saw those dry fuels that continue to smolder through the drier periods. And in fact, we had a lot of fires that came back to life from several weeks to as many as 45 days after those prescribed fires were considered completed. We also had to put on extra resources to monitor those fires as we saw the wildfire activity increase. For the next slide, as Pam alluded to, when we think about dryness in the fire environment, there are many ways to measure it besides the drought monitor. Those 4 images on the left are some various ways of looking at atmospheric and hydrological drought leading into the wildfire activity we saw in South Georgia there in late April. On the upper left, vapor pressure deficits are a big one. This is the 7 days leading up, basically showing record high dryness in the atmosphere that allowed those fires to really take hold of the landscape. The energy release component on the bottom left set records compared to the most recent 20-year climatology. And then in the middle there, I really like this convergence of evidence product from d3drought.org, where you can look at various timescales of precipitation and evaporation across the region and combine them into a single product. So showing really extreme conditions there across the southeast through the fall, winter, and then into spring. On the right side there, we also look at KBDIs. That's one of the standard measures of dryness based on temperature and precipitation. I really like this anomaly product from the Midwest Regional Climate Center, showing those well above normal values, indicative of the drought that continues for the Southeast, but we did get some improvement from the Florida Panhandle into Southwest Georgia with the rainfall earlier in May. On to the next slide. So they'll spend the next few slides talking about the types of fuels that burn and how they could be affected by drought. Go on to the next slide. Dead fuels are most important during the dormant season. So think of basically leaf off in the fall through spring green up. And those 1,000-hour fuels, those 3 to 8 inch diameter trees and logs that are dead are most important for drought. So if you look at the upper right there, this is another fire danger graph from Waycross, Georgia, comparing this spring to some other big fire years, 2011 and 2017 there in South Georgia. So the lower the 1,000-hour fuel moisture, the drier the fuel is, and we set records again with that 1,000-hour fuel moisture there in late April, worse than any other time over the last 20 years or so. With the rainfall that we got, those did improve dramatically there during the end of April into early May. It's worth noting that some of those other big fire years had those dry conditions continuing well into May and even June for some years. On to the next slide. So for live fuels, that image on the upper right from Florida looks very green, but those live fuels are extremely dry and volatile. Some of the chemical compounds they produce are highly burnable in the spring. Unfortunately, when you have dry soils as well, that makes them extra burnable. There's just not as much water in the landscape. And as we continue to see drought impacts through the next few weeks and into the summer, that'll be something to watch very closely because the live fuel moisture can actually decrease again during those flash droughts. And then on the bottom right, ground fuels are also highly burnable when they're dry. This image actually shows, a high water table. But if you're seeing the conditions we're seeing now, those organic soils that are carbon rich produce a lot of smoke and can lead to some long-term fires that we're seeing across the Southeast. On to the next slide. One of those that we've dealt with this spring was the Highway 82 fire there in Georgia. Really impressive image from some of the aircraft that were flying that day in late April. Of course, produced a lot of smoke, and that really started to grab the headlines as that smoke headed north towards the Atlanta metro there, as you see on the upper right. When the fuels are extremely dry, one of the things that we saw this spring was that our typical fire weather thresholds really were not applicable. So we worked with the Weather Service to adjust some of their thresholds on some of those most critical days when the fuels were really driving the fire activity. We haven't seen any active fire on those South Georgia fires over the last few weeks since we got the good rainfall, but they are still burning underground as deep as 3 to 5 feet under the surface. So that's something we'll have to watch closely in this drier and hotter stretch we're seeing. Next slide. Some of the other lingering impacts on the left there, this is from the Sargent fire along the Florida-Georgia border. So those pine trees were scorched by the Sargent fire. A few weeks after the fire, they start to drop those needles that did not burn in the fire. And so we could actually see reburn of that fire in its existing footprint if that ground fire comes back towards the surface. Then down in Florida, as we head into the rainy season, this is a typical time of year when we do see an increase in lightning started fires. We did get one of those, actually 2 near Naples, Florida yesterday that ultimately got rained out. So those scattered thunderstorms that we see this time of year are a big driver of our fire activity. And that's something that we'll likely see in the areas of drought over the next several weeks at least. Next slide. And then Helene, we've seen a lot of attention drawn to the Helene impacts across the Southeast and its impacts on wildland fire. Of course, some of those fires in South Georgia were near the edge of the more extreme damage. This image on the right is from the mountains, North Carolina and Buncombe County. So I think it does a good job of illustrating the impacts that we could see even now that we're into green up. On the upper right portion of the screen, the areas that are shaded by leaves now really aren't going to be susceptible to fire despite the drought that's ongoing. You still could get some small fires in there, but as we saw in the North Carolina mountains over the weekend, some of these areas with severe lean damage that have the blowdown are much, much drier because the sunlight is able to penetrate those dead fuels, dry them out, and then we can get at least some smaller wildfires that are challenging because of the number of trees that are across the landscape there. Next slide. So moving forward, I wanted to look at some of the El Nino analogs that we're thinking about heading into the summer months, how that may impact the drought. Those El Nino years tend to be quite hot across the southern tier of the region, especially Florida into southern Alabama. Unfortunately, 2023 is a really close analog to what we may see this year. We saw some intense flash drought impacts that year. Kind of unusual to have the drought that we have now and then see that happen later in the year. So hoping that doesn't come to pass. Fingers crossed the wetness in the Appalachians pans out ahead of the fall fire season. Next slide. And then that flash drought in 2023 was really impactful to some of our pine trees in the region, especially in the coastal plain. As those trees become drought stressed, we see beetle infestations from southern pine beetles, which is shown here, and then Ips beetles as well. really impactful, causing a lot of tree mortality there across the coastal plain in the southern US. So if we were to see flash drought with the dryness that we have now over the summer months, we could see additional pine mortality across the coastal plain in the southeast. Next slide. And then finally, on the left, we have a fuels and fire behavior advisory out there for the Florida Peninsula and to South Georgia and the coastal Carolinas that runs out through the end of May, describing some of the impacts I've talked about here. Low water levels are a major factor in fire activity there this time of year. That'll be something we'll be watching closely. And then on the right is our significant fire potential outlook for May and June on the top, July and August on the bottom. So with the lingering drought, the potential for heat waves this summer, we do expect above normal activity across the southern tier of the US. Could be challenging for a national perspective just because we could be competing for resources with the western US due to their snow drought. That's all I have for y'all today. Thank you.
All right, thank you. My name is Aaron Mayhew. I'm the HAS forecaster at the Southeast River Forecast Center. We'll go ahead and take a look at some of the water resource and stream flow conditions over the past month or so. So first looking at the 28-day average stream flow anomalies across our area, you can see we've had a little bit of improvement lately over Alabama, particularly Central and South Florida continue to be a little wet, but much of the areas in the Carolinas, Virginia, much of Georgia continue to be quite dry. As far as rainfall over the past 28 days, we did see a couple of weeks of some decent rainfall activity as cold fronts were able to come through and push out some of the persistent high pressure that had been sitting over us, keeping us quite dry. There was a few areas in Alabama that actually saw 10 to 15 inches of rain over the past 30 days or so. But once we get outside those orange areas that are indicating, 3+ inches of rain, most of the other areas were, at least 75% or less of normal precipitation. And up into the Carolinas and Virginia, they certainly fared the worst. They were only about 25% of normal or so. Now, I did mention we've seen some improvement. Again, much of it was in Alabama, but the last time we looked at this at the end of April, there was about 490 or so gauges that were extremely below stream flow anomalies. That's about 63% of the gauges that are in our area. And at this time, we're about cut that in half to about 260 gauges or so, or roughly about 33%. But, we are entering into a period of the year where those stream flows are getting lower and lower anyway. So some improvement, but a long way to go. Go ahead and go to the next slide. And we can kind of see that reflected as we look at these statewide stream flow runoff plots. On the far left there is Alabama. You can see after being quite low in kind of the extremely below normal territory, it was actually able to creep up into the just regularly below in a 10th to 25th percentile. But they probably have fared the best as we get over to Georgia. Their improvement is just barely getting up into the 5th percentile, and Florida is also in about the 10th, but again, that's largely driven through central and southern Florida. Now, if we go to the next slide, we can see the Carolinas and Virginia are continuing to feel the effects of this drought. The stream flows have really tanked since last spring. We're getting down into the well below normal and kind of driest ever territories. So not a big surprise given the conditions, but it's kind of start to see on a graph like this. And I think that might be the last slide, Elliot. Oh, our current conditions, no surprise, as dry as it's been. We're not seeing any flooding right now or even really any action stages. So our forecast points have been fairly quiet.
This is Cooch here in water management. I just wanted to do a sound check real quick.
Yes, we can hear you, Bree. Thank you.
All right, next slide, please. Starting at the headwater project of the ACF Basin, the next several slides are going to heavily mirror what we've been hearing throughout this entire presentation. Lanier is currently in zone 3. We are more than 5 feet below the top of conservation for this time of year. And if conditions persist, we are forecasted to possibly enter zone 4 if we don't see any improvement. Next slide, please. Here we're looking at cumulative inflows for this water year. We've got several selected years, as well as the historic median there in black. If you'll notice, the red line indicates where we are for 2026. And it's not looking great, frankly, in terms of inflows. Next slide. These are our percentile inflows for the project. And this is currently the third driest year on record for Lanier in terms of those inflows. Next slide. All right, West Point, we were able to see some slight recovery from the precip that we got for the last 2 weeks, but we are forecasted to continue on a decline again with current conditions, but we are above the top of conservation, still below historic median for this time of year. Again, we're looking at cumulative local inflows for this project. So these inflows do not account for any water that we have routed downstream from Lanier. This is strictly local inflows into West Point's tributary, very heavily mirroring the year 2008, as we've been seeing in terms of drought conditions. Next slide. And this is currently the driest year that we have for the period of record at West Point, under the 5th percentile for local inflows. And Walter F. George, similarly to West Point, we were able to see some recovery from the last 2 weeks of precipitation. We're going to be trending towards the historic median over the next several weeks. Minimal storage at this project, but we are very thankful that we are above top of conservation at this time. Again, Walter F. George's cumulative local inflows for this water year, we're below 2012. We're actually, if you go to the next slide, this is also the driest year for the period of record at Walter F. George in terms of cumulative local inflows. Next slide. And here again, similarly to what we've been seeing, these are the Chattahoochee flows for the period of record, and we have broken several historic lows as of 2026. That dark gray does indicate period of record high and lows, as you'll see from the legend. We did see some improvement into the normal, but we are heading back down to minimums for this time of year. And this is the ACF Basin composite storage. Once we hit composite storage zone 3, we do enter drought conditions, which we declared as of May 1st. We did get some precip pretty closely after that, and we were able to enter composite zone 1. We will reevaluate our drought declaration the first of the month. So as of June 1st, we will declare whether we're going to remain in drought operations or if we are going to end those operations at that time. Next slide. I think that's it for us. Mr. Jones, did you have anything?
Hey everybody, this is Phil Fragapane. Thanks, Bree. I'm a water resources engineer with Duke Energy, and I'm going to tell you about a couple of regions for which Duke manages what we call low inflow protocols. That's kind of a fancy way of saying drought response plans. And so these are regional drought response plans. All large water intake owners participate in this process, and they set their drought response triggers all collectively to these same low inflow protocol stages. So let's start with the first one. It's on the next slide. It's going to be in the Savannah River Basin's depicted there on the left. The Savannah River forms the border between Georgia and South Carolina. And so this particular region extends from the headwaters of the basin up in the Bag Creek, Jocassee, and Keowee are three lakes that Duke Energy operates. And then as you go downstream, there are three lakes, Hartwell, Russell, and Thurman, that the U.S. Corps of Engineers operates. We have an agreement between Duke and the Corps for sharing those storages during drought. If our storages get above as a percentage of our full usable storage, the same percentage for the Corps, then we release water downstream so that we try to balance those storages. So that's the region. Let's look at how what the low inflow protocol is for that region. So there's a lot of information on this. This more or less shows you all the boundaries between the trigger points. There are three triggers for the low inflow protocol. There's a reservoir storage trigger, a stream flow trigger, and a U.S. drought monitor map. So you can see from this, it's pretty easy to see with this graph that currently the reservoir storage supports stage 2. The stream flow triggers are almost at the stage 4. They're just at the bottom of the stage 3 zone. And the U.S. drought monitor is at stage 2, headed towards stage 3. In order to declare a drier stage of the LIP, there's two things that has to happen. One, the reservoir storage must support that drier stage. And two, one of the other two triggers must support that drier stage. So it's really kind of the reservoir storage that drives things. And so let's move on to the next one. This is a little, I enjoyed the historical context that Chris provided. This is not as long of a history, but you can see that since we've been operating this low inflow protocol in 2016, it's not unusual that we reach stage 2. We started in the drought of 2016 and stayed in stage 2 for over a year. And then a couple of times since we've reached stage 2, we've reached it again. And but this feels like you know, the beginning maybe of a deeper, drier period. So let's go to the next one. So as I mentioned, it's the reservoir storage that drives this, and the long flow protocol follows the Corps of Engineers drought plan. They have sort of a parallel drought plan, and so as the Corps of Engineers drought plan are triggered, then the LIP also follows that. This shows that the only sort of upside here is that this shows that the lakes are just barely on the stage. They've just crossed over into the stage 2. In order to reach stage 3, one of these two lakes would have to reach the stage 3 trigger, which is that horizontal line at the bottom. And they're both, looks like maybe 6 feet or so above that. So there's still a little bit of storage left until we reach that stage 3 level. And so this is the other region. It's the Catawba-Wateree River Basin. You can see it's sort of around the centroid of North and South Carolina. It's a series of lakes, all operated by Duke Energy. I think it's 11. Yeah, there's 11 lakes. And the largest of those lakes are Lake James, Norman, Wiley, and Wateree. So those are sort of the most important storage lakes. So let's look at the overview of the LIP for the Catawba-Wateree, CW we call it. It's a similar story. Our reservoir storages are support of stage 2, and the stream flows, they look like they were right there between 3 and 4. And, you know, the U.S. drought monitor, it's a very similar story from trigger wise. So we reached stage 2 on May the 1st. And so we are going deeper. So the next slide, I think, let's see, what does it show us? Yeah, that's the same historical context. It's very unusual for the Catawba-Wateree to reach stage 2. There's only one time since 2006 when we started using this low unfold protocol that it's reached that, and that was the drought of record. It reached as far as stage 3, and it stayed in stage 3 for over a year at that time. And since then, we have not gone past stage 1. A number of times we've reached stage 1, but this is the first time since the drought of record that we've reached stage 2. And so I think the next one might show us a little bit about where we're headed. So as I mentioned before, it's really the reservoir storage trigger that drives where we're headed because the stream flows have just been so low. So if the reservoir storage trigger reaches 3, then the LIP stage is going to reach 3. So this shows you that we, every drought is different. What seems different about this one is that the intensity of impact on our reservoir storage occurred right at the time of year where you're generally filling up your lakes. And so you can see here that between March and May, it's like a 5-week period where the lake storage crossed all of these triggers. And that's because it was just, we've had so many months of depressed inflows that the lake storage began to break and just couldn't sustain that. And so it started crossing over these triggers in March, and with like a 5-week period, we crossed 3 of them into stage 2. You can see we're in stage 2 now. We got a little bit of rain about a week ago, and that helped. They've got a little bump up, but you can see now we've already begun to decline now with the reservoir storage. So we're not close to stage 3, but I think we may well get there, unless this drought breaks over the next few weeks. And so, yeah, this is the headlines. This is a collaborative approach. All large water intakes are participating. They're all now declaring mandatory water restrictions with the goal of 5 to 10% withdrawal reduction as compared, to a normal period of drought. So it's a collective collaborative approach, and it's all geared toward buying time until it starts to rain again. I think that's all I had to present. I appreciate your attention.
Yes, thank you so much to all of our presenters so far who have given the sectoral updates and climate conditions and drought conditions. We're going to move into the state updates, starting with Alabama. We're just going in alphabetical order here. But I also wanted to take this opportunity to let everyone know, again, if you have any questions, use the Slido app down at the bottom instead of the direct chat, and we'll answer your questions there, and you can put them in now, or you can go ahead and wait until the end, either way. But I will kick it over to Harper to give an update on Alabama next.
Thank you. My name is Michael Harper. I'm a water resource engineer with the Office of Water Resources. Go ahead to the next slide, please. And I thought I'd take just a moment to describe what Alabama does as far as their drought management, according to the drought plan, and how a little bit of that structure looks. So starting at the bottom, we have what we call our Monitoring and Impact Group, or MIG for short. I'll refer to that group a lot. That group is a subcommittee of the Alabama Drought Assessment and Planning Team, or ADAPT. And then that group reports anything drought related to the governor's office. All right, next slide, please. So digging into a little bit deeper, looking at what the Monitoring and Impact Group is, or the MIG group is, that group is a technical subcommittee, collects a lot of data. It's made up of multiple groups, state, federal agencies, reservoir managers, Forestry, a lot of the groups here, Corps of Engineers is part of that group. And we collect a lot of information looking at impacts as well as conditions, stream flow, groundwater, soil moisture, things like that. Do a lot of data analysis with that data, and then they make recommendations based on the data to and issue what we call drought declaration from the state of Alabama. The ADAP group is a more of a senior level advisory body. That group is composed of a lot of cabinet members, a lot of state and federal agencies, as well as governor appointees as well. Takes the information from the MIG, from OWR, and from others, and then turns around and kind of gives the governor an update of conditions, if any recommendations are to be made as far as any kind of declarations or things like that at the state level. All right, next slide, please. Go ahead. I know we've gone over a lot of indicators. I just wanted to highlight here, looking in April, the state was at some of the worst drought it had ever seen for that time of year. And so our committees were meeting, our MIG group had been meeting regularly and are continuing to meet at least monthly since September of last year. There were a couple of times where we actually met twice in 1 month as conditions were worsening. In April, we also pulled together the full ADAP committee meeting just to let everyone know what was going on. And then we've been in constant contact with the governor's office since then. Since that meeting, we have received some beneficial rainfall, as Chris showed earlier in his presentation, that has alleviated some of the temporarily alleviated some of the drought conditions that we've had. But what I've got circled there in the middle on the bottom, just an indication of, even though we've gotten some relief, we still need roughly a foot of rainfall to get us completely out of this thing. All right, next slide. And this is a product that we produce weekly in our office, a drought portal, GIS drought portal for stream flows, and this shows a 30 and a 60-day average. Taking things a little bit further out than what we see, with some of the other products, and it still shows, long term, we're still having a lot of stream gauges across the state, record low territory. We're writing new record lows every week at these long term 30 and 60-day averages. The next slide, please. And as a result of our last MIG group meeting, this is the current Alabama drought declaration that was released. It does show some improvement from our previous one. Just wanted to highlight here that while we have experienced some modest, I would say, short-term improvements due to some of the recent rainfall that we received, we need consistent, sustained beneficial rainfall through the summer to get us out of this drought. All right, next slide, please. And just as a reminder for those who may be interested, our next monitoring and impact group meeting for the state will be held on June the 10th at 10 a.m. The meeting is open to the public. If anyone is interested in joining the meeting, you can go to the Alabama Secretary of State's website, search ADAP, and you can register to receive notifications of future meetings. And the meeting link will be posted in the agenda there for everyone if anyone is interested. And I think that's all I have.
Okay, thank you very much. This is David Zierden. I am the Florida State climatologist at Florida State University, and I've been working with NIDIS and the U.S. Drought Monitor for many years now. So I'm going to go ahead and kind of look closer at the state of Florida and focus more on impacts than raw numbers. We'll start off with the U.S. Drought Monitor. Chris Fuhrmann went over this very well and where this current drought ranks. But in the state of Florida, right now, 99% of the state is in some category of drought from D1 to D4. It was even 100% back in March and April. 80% in exceptional drought, which is either extreme or exceptional drought, D3 to D4. This is the most since the inception of the U.S. Drought Monitor in January of 2000. It's the first time we've experienced that D4 or exceptional drought since 2012, and is widely considered the worst drought since 1998. That didn't show up, that year didn't show up as much in Chris's presentation because it was before the U.S. Drought Monitor, and also it was more localized to the state of Florida than the greater Southeast, but we still remember it well. So we'll go to the next slide. We'll start talking about impacts, and several of our speakers have gone over this, the hydrologic impacts and stream flows. This map on the left shows everything with a dark red dot is stream flows that are at less than their 5% of historical average. So yeah, it's pretty dire. There was some improvement in the Western Panhandle, but the Suwannee River and Santa Fe River Basin are still very, very dry. The biggest problem is the winter season. December or January through March should be the recharge season for these rivers and streams from South Georgia, South Alabama, the Florida Panhandle, and North Florida. But now we're over this winter recharge season, and they're still at historic low flows. So that does not portend well through the coming of summer, when stream flows and rivers usually drop even further. A couple pictures. The top right is the Santa Fe River, which you just see it north of Gainesville, Florida. All you see is a dry riverbed in this area. The bottom right is Little River Springs on the banks of the Suwannee River. If you look carefully, there's a seawall or retaining wall 6 to 8 feet higher than the water level. That should be full pool when people can swim there. Right now, the spring is still flowing, but really unusable. So the next slide, we'll switch to South Florida and the hydrologic impacts. On the upper right is the current lake levels for Lake Okeechobee. We see they have been below average since about February of 2025. So for over a year, now a half, we've been below normal lake levels at Lake Okeechobee. We've been flirting with that water shortage level, the black line on the bottom. Haven't surpassed it yet, but it's been a prolonged area of low lake levels. But the real hydrological impacts are even further south. The water conservation areas shown in the dark red, Big Cypress National Preserve, the Everglades, water levels in the wetlands there are extremely dry. And we'll talk about this in a slide or two. That means that the wetlands have dried up, the grasses are very flammable, the natural fire breaks that should occur with these wetlands have dried up. So it sets the scene for big and prolonged wildfires in this area. So we'll go to the next slide. I want to talk about soil moisture. Over on the left is a NASA product remotely sensed via satellites that shows basically soil moisture in the upper 100 centimeters of the soil. You see how extremely dry it is, down into the 2% range in the Florida Big Bend, along the west coast, and even pockets of southwest Florida. But I also want to call your attention, the Florida Automated Weather Network, administered by University of Florida, has installed soil moisture sensors, on-ground measurements of soil moisture across the state. And over in Bronson, Florida, which is in the Big Bend, you see it's flatlined to less than 2% since April, and even a couple small rain events did not change it at all. Further south in Immokalee, Florida, kind of the heart of the citrus territory, we see a response to a couple 1-inch rain events recently in the upper levels of the soil, but the deeper levels, no response at all. So this is a really effective tool to help verify what the satellites are seeing and give us a better picture of soil moisture across the state. So with the next slide, we'll talk about the wildfire threat. Andy Snyder covered this very well. Top left is the current Keach-Byram drought index by the Florida Forest Service over the state. Everywhere you see the darker orange or red, it's over 600, which still indicates very dry fuels and upper levels of the soil. We do have outdoor burning bans for over 30 counties that I show in the other map. Currently this year, we've had 136,000 acres burned, which is significant. It doesn't approach the 500,000 to 600,000 acres burned in 1998, but it's still significant. And here's a list of some of the noteworthy wildfires recently in the Big Cypress National Preserve, over 30,000 acres. More recently, Everglades fires near Miami and Broward County, a fire in the Panhandle that destroyed dozens of homes and outbuildings. So we'll go to the next slide. Going forward, what can we expect? The official start of the summer convective rainy season is May 15th, which we've already seen. The problem is if the rainy season is late to start or less than robust with the increased temperatures and evapotranspiration, impacts really mushroom. So looking at the 7-day precipitation forecast, it looks mostly dry. Some sea breeze convection possible along the southwest coast, but not much to speak of. Looking further ahead, it was mentioned that El Nino is being strongly forecast for late summer and fall and the winter. Some call it a super El Nino. I don't like that terminology. The impacts, it may lead to a less active hurricane season, which would mean less tropical rainfall, which is not good for the drought situation. The excess rainfall we normally expect in the state from El Nino usually doesn't start until the fall of the year, late October or November. So even though El Nino might be on the way or develop early, it's not going to bring us any real relief until the fall. And we saw that in the analog from a previous speaker. And just a couple pictures to tie it up with. There's the national fire in the Big Cypress National Preserve via satellite. And also here's a snapshot of ranching operations down in Okeechobee County, where you see nothing but dry grass and a watering pond that's about to dry up. So with that, I'll turn it over to the next speaker.
Bill Frechette from the state of Georgia. I represent the Georgia Environmental Protection Division, the Water Supply Program. Next. Realistically, we're in bad shape. 90, 120, 180-day departure from precipitation means we need on the order of 12 inches to more than 12 inches of rain to come back to anywhere near normal. Next. Whoa, the maps were left in. We've seen these before. They're ugly pictures. It's dry out there. 90-day departure. Again, we're on the order of a lot of rain is needed. Next, I think, is 120. And the next one is 180. Things get ugly out there. But we've seen all of that before. In terms of stream flow, one of the people had the stream flows USGS gauges where Alabama was looking pretty good. Georgia's still dry. The monitored USGS gauges show below 10 percentile, 17 show below 5 percentile, and 2 with record lows. Updating that, there's probably more with record lows. Groundwater levels are low, below the 10th percentile, and 12 show levels below the 5th percentile with 1 record low. As we've seen, reservoir conditions, Lake Lanier is in zone 3, ACF composite is zone 2, and Hartwell and Thurmond are also in level 2. We're hoping, as we project, the Climate Prediction Center outlook has a mixed message. We've heard some indications of we may get some rain Others were maybe hotter. And listening to the stuff this morning, hotter and drier doesn't probably make it a good outlook for the summer. And in terms of our water supply providers, metropolitan areas, municipal provide, we've had a few complaints about water problems so far, but generally people are trying to get by. Next. The state of Georgia is currently in an announced current drought response level 1 that was announced on Monday, April 27th, and it requires public water systems to conduct public information campaigns and explain to all their customers drought conditions and encourage conservation. Not a requirement, but they have to do that, put in the bills, put in the flyers, take out ads and stuff. There are some limitations on water use. Don't irrigate during the heat of the day to avoid evaporation, and encourage customers. They should be good stewards of the water resource. We have this with regular meetings of the high mucky mucks that get together and try to determine and make a recommendation of drought levels. This happens regularly, and at present, there are continued ongoing discussions and considerations of enhanced drought response levels and state actions. If that announcement comes through, it goes up to the governor. The governor makes the announcement, and that would require automatic cutbacks, industrial cutbacks, and such if we ever get to level 2 or level 3. But at present, we're in level 1 information, and hopefully it rains and it goes away. If things get worse, obviously we're going to have to take action. Next. Back to North Carolina.
All right, so I am Klaus Albertin. I'm the chair of the North Carolina Drought Management Advisory Council. Next slide. Yeah, I mean, no surprises to anybody. Conditions are looking pretty bad statewide. The entire central and western part of the state, for the most part, is in extreme drought. Coastal plains a little bit better in severe drought, and the northeast part of the state's been getting some of the rainfall, so they are the only area that's only in moderate drought. Next slide. Just looking at deficits, you know, it's the same stories as the rest of the Southeast. Continued dryness with occasional storms improving things, but you know, really since the beginning of the year, it's been a very steady decline, and then the last month and a half have been extremely dry and hot. We knew things were going to get bad the way things were trending, and it just has continued for the most part. We're at about 15-16 inches behind in the last 6 months, with Boone now being about 21 inches below normal, since the beginning of the drought. And yeah, we saw it before. A lot of good presenters at the beginning of the meeting today. 95% of the gauges are either below the 10th percentile or showing a record low for the day. It's actually been a little bit worse a couple weeks ago, and some stations actually moved into the only 10% below normal, but it's been an extended stretch of record lows for the day. So I think when we look at it in the future, looking at 7Q10s and some of these low flow statistics are going to change just because of how long these stations have been at that record low. Next slide. So the issues, for ag, 57% of pasture was in poor or very poor condition. We've heard of some ranchers trying to bale hay, and yields are pretty low. Already started feeding with supplemental feed in a lot of places. We got a national natural disaster classification last month for 40 counties. I haven't seen anything yet, but I expect at least 2/3 of the state is going to be in that natural disaster pretty soon if it hasn't already shifted to that. A lot of farmers held off planting corn, hoping that conditions would change. Some did a few weeks ago, kind of at the very end of their planting period. Others shifted to cotton and soybean just because of the, more resilience to the drought and hoping they can get something out of it. Water supply, Phil mentioned it, the entire Catawba-Wateree works in coordination. So based on the reservoir levels and the LIP, they all go into the same conservation level at the same time. That's been the biggest area of mandatory conservation, but also the Neuse, City of Raleigh, has gone into mandatory conservation. We've got another 57 systems that are involuntary. And, that number is going to keep climbing pretty quickly. I know Army Corps of Engineers is looking to get a variance from their normal minimum flows at some gauges. So, the entire Neuse is going to probably start to see mandatory conservation if they're on the Neuse for supply. Recreation, as part of the LIP and operating rules, a number of the rivers are allowed to cut back on recreation releases during drought conditions, and they're doing that. Definitely starting to see issues at boat launches and warnings from wildlife resources about hazards because of the low water levels and potential for hitting submerged tree trunks. And just an example, Fontana Lake out in the western part of the state is 18 feet below normal. Next slide. Water quality, we're starting to see water quality concerns. In general, despite the low stream flows, a lot of the reservoirs were in good shape just because they were operating them as conservatively as they could. But, with the increased heat and increased demands, really starting to see the impact of the lower flows. And then down at the coast, we're starting to see saltwater intrusion because of the low freshwater flows coming from upstate. So there are some issues already at intake down here at the coast. Next slide. Yep, and that is it for North Carolina.
Hi, my name is Jennifer Simmons, and I am the Water Resources Climatologist with the state of South Carolina, work for the South Carolina State Climate Office within the Department of Natural Resources. So we've heard a lot about the data and how things just have been very dry and not looking good on many different scales, but I wanted to look a little closer at the impacts that especially the folks on the ground are experiencing. So agriculture has taken a major hit without that recharge that folks have been talking about, the lack of rainfall over the fall and especially the winter. So dry fields have stalled spring planting. There are a lot of folks that needed to start planting in March and had to delay the planting. The lack of beneficial rain and exhausted water supplies led to poor germination or delayed planting. The no winter recharge continues to impact farmers. So there's pasture shortages, low spring hay yields have been worrying the livestock producers. And now that we're leading into these warming temperatures and higher evapotranspiration, will lead to even worsening conditions. So folks are definitely worried, especially those who rely on, say, their irrigation ponds that were not allowed to recharge and refill over the winter time. Forestry has also been impacted. So with the below normal precipitation since September 2025, which you could see on North Carolina's graphic, it's the same sort of thing. We've been on a slow decline. We've had extremely dry conditions, especially in April, which led to a 14-day long South Carolina Forestry Commission started a bird ban across all or portions of the state, and has also yielded above average wildfires in March and April. In many areas, as the speakers were talking about earlier, that were hit by Helene, there are a lot of dry, sorry, forgot my words, but just dry products available that can lead to these burns. So water resources. Many streams remain at daily all-time lows with little improvement. We can see just a slight occasional precipitation will help, but without any sort of continuous beneficial rain that impacts, we're just not getting that improvement. Groundwater remains below normal and is continuing to decline across most of the state. Lake levels and reservoirs, which Duke Energy they spoke about, we're continuing to see the decline. Lake Thurmond and Lake Hartwell, which is down 7 feet. And a picture there we got from Clemson DNR shows the lake levels at Lake Hartwell. Next, please. So the South Carolina Drought Resources Committee meets and consists of 5 state agencies and 42 local representatives that represent the state, and their role is declaring drought levels and enforcement of drought response at a local level. So they vote on a countywide scale, and so last meeting was April 30th when all counties were declared in severe drought status. Just wanted to let you know too that these meetings are open to the public. The next meeting is this Thursday at 9 o'clock. All information can be available at scdrought.com. Also, the water resources have led to now 26 water systems have activated their drought plans and are requesting voluntary water conservation measures. Additionally, 11 water systems have implemented drought plans that require mandatory water conservation. And this is this was submitted on the 15th of May. So as of May 15th. And state contacts available at any time. You can reach Hope Mazzell, who is our state climatologist, and myself, mentioned Jennifer Simmons. We are all available via drought@dnr.sc.gov. Thank you.
Hi, Will Tollefson with the Tennessee Climate Office. In Tennessee, kind of a story similar to the rest of the region, we've seen this drought kind of lingering over the fall and winter and really ramping up as we've gotten into the later spring in 2026. We did get kind of light rainfall, precipitation events, snow throughout the winter that kept things pretty steady, but they were always a little bit below average. And so we saw those deficits really start to creep up. And now that we've entered into the warmer season, those drought conditions have really expanded. In Tennessee, we don't have as kind of set of a group looking at this at the statewide level, but we do have a drought and wildfire task force that meets monthly whenever we have drought conditions in the state. And so we've been working on that over the last seasons. That's headed by our state emergency management agency, and we have representatives from the climate office, environment and conservation department, TVA, forestry, ag. And so looking at all of the conditions across the state in communication, kind of really keeping tabs on everything. Like mentioned in the other states and reports, our stream flows have been very low, many gauges showing record low stream flow for the date. And just kind of showing that as we head into our summer season, that's when we typically see a drop in those stream flow levels. And so while we have had these record low stream flows in the spring, we're kind of running on normal range for more late summer, fall. If you go to the next slide, kind of talking about our impacts, We've had similar kind of concerns with agriculture, specifically hay and pasture being the biggest impacts. Although the warmer and drier spring helped row crop planters, they're well ahead of average planting and for kind of emerging, but we're starting to see some reports that they're not really growing now that we've entered in this hotter, drier condition. So we're concerned about that going forward. Stream flow, again, below average, mostly our TVA reservoirs, a lot, especially in the tributary reservoirs, are running below average for this time of year. From the TVA, they're reporting that many of those tributary reservoirs in the eastern kind of portion of the state in North Carolina and other parts of the basin, probably not going to reach their summer pool targets, which should be at the end of the month for recreation. So we're keeping an eye on that. But with our current conditions, there are no kind of utilities having concerns, not being able to meet demand. But TDEC, our Environment and Conservation Department, has been in communication with all of our local water systems, basically just requesting they review their drought action plans, report any issues early as possible so we can stay on top of the situation. As far as wildfire goes, we did have a pretty active season, but it was well managed. We had several fires, but none got too big or spread too far. We actually, acreage wise, were a little bit less than last spring. But you can kind of see once we got into our leaf out April, May, we did get some beneficial rains, especially southern kind of bands of the state. Those fires have started to calm down. So in Tennessee, we are kind of holding steady, hoping for rain as we head into the drier, hotter season.
Thank you so much for all our state presenters. I know that we are actually at time. So if you have to drop off, I totally understand, no worries. We are going to cover quickly what's coming next, as well as the outlooks and what we need to get out of drought. The webinar recording will be sent out after the presentation sometime later this week. And we'll go ahead and continue with the presentation. All right, so what do we need to get out of this drought? Well, the answer is rain. That's not necessarily a shock given all the what has been said by all the presenters. What I have here is the rainfall needed to improve drought over the next 3 months. So this isn't necessarily to bring us back to normal. This is just to bring us to a less intense level of drought. And this is done at the climate division for each state. And so anywhere where you see the lighter colors, that's technically a less amount of rain. And where you see darker colors, that's a higher number of rain. And so on the right here, I have the rainfall range for the low end and the high end for the different climate divisions across each state. So depending on where you are in Alabama, you need somewhere between 12.5 to over 17.5. Florida, it's 19 to 28.5. Georgia's 14.25 to 20.5. North Carolina is 15.5 to 19.2 roughly. South Carolina is almost 15.5 to 23 and almost a half. And then Tennessee is 13.25 to almost 16 inches. So over the next 3 months, we need a decent amount of rain to really improve the drought conditions here. And so on the next slide here, this shows the probability of the improvement. So this is a little bit of a flip. So if you see darker colors, now this is a lower percentage probability of improvement or improvement over the next 3 months, where if you see a lighter color, it's a better improvement. And so again, you can see these ranges based on the climate divisions for each state, where Alabama ranges from 31 to 40.5. Alabama 31 to 40. Florida is 9 to 53. Georgia is 18 to 38. North Carolina is 8 to 52, or almost 53 there. South Carolina is almost 13 to 58, and Tennessee is 7 to 48. So it depends on what climate division you're in for the percent, but generally we don't see a lot of good probability of great improvement over the next 3 months. And I think with that, I will turn it over to Aaron to just give a quick update on the climatology for flood here going forward.
All right, go ahead and go to the next slide there. So this is just an overall look at our typical flood climatology for gauges that have a long enough period of record. We went back to 1975 to 2024. We're in the process of updating this a little bit, but the key thing to look at here, as we are currently in week 21 of the year, this is typically our slowest time of the season for both minor and moderate or higher flooding. That's over our entire area. If you go ahead and go to the next slide, let's look at Florida. And you can see a slight uptick that begins as the summertime convective season begins before it really kicks in full overdrive for the fall and tropical season. So overall for our outlook, if you go ahead and go to the next slide, not too much of a surprise given the dry conditions, and while there are a couple areas that are marked in the CPC outlooks for some above normal precipitation chances, it's not really going to be enough to do a whole lot. So the flood risk is already low, and we're probably looking at below normal chances for flooding over most of the Southeast for the next few months.
All right, good morning, everybody. This is Andrew with the Weather Service in Raleigh for basically some forecasts and outlooks for ENSO and effects on the Southeast. So 7-day rainfall, majority of the precipitation actually is forecast to reside, across the lower Mississippi Valley, parts of Tennessee Valley, Ohio Valley, and portions of the Carolinas, across like Florida. I think one speaker mentioned earlier that a lot of that is going to be driven by sea breeze, convection, and any other kind of subtle boundaries there. This rainfall forecast is highly dependent on, obviously we're getting into the summer season, so a lot of the storm activity is going to be, very isolated, scattered in nature. So we'll just have to kind of see how that pans out. If you go to the next slide. 8 to 14-day outlook, we are expecting slightly favoring above normal precipitation, especially from the lower Mississippi Valley into kind of the deep south and parts of Georgia, Alabama, South Carolina, and Florida. Although we are expecting that favorability for above normal temperatures as well. So given that this summer season, we're getting into like isolated scattered storm activity, areas that don't see the rain could see the conditions get worse. Go to the next slide. Seasonal outlook. This hasn't updated recently, but it's been, been out there for a good portion of the last several weeks. This is from May through the end of July and largely favors a slight favoring above normal rain, but in a small area of like southern Alabama, Florida, eastern Georgia, South Carolina, and eastern North Carolina. So not a large portion of the Southeast, and a better signal for favoring above normal temperatures, especially across eastern Tennessee Valley and parts of the southern Appalachians. So you can go to the next slide. With that, we aren't expecting, a dramatic improvement in the drought for some areas, like along the Appalachians, Georgia, the Carolinas, and into Virginia. So that is predicted to persist across those areas. Generally, this forecast does show improvement or even potentially an end to the drought by the end of July for portions of Florida, lower Mississippi Valley, Tennessee Valley, and parts of Alabama. So hopefully that will end up verifying, but we'll just have to kind of see how the pattern shakes out. Go to the next slide. So El Nino and La Nina, so we have come out of the winter season where La Nina was a large factor. It has gone into neutral, and its ocean temperatures are favoring a quick development into El Nino right now. So what is ENSO? For those that don't know, it's the El Nino Southern Oscillation that includes El Nino, La Nina. El Nino favors a warming of ocean waters in the central and eastern tropical Pacific, and La Nina favors kind of the opposite. So we are in that neutral phase, and that should hold into potentially early June. But we are expecting, Climate Prediction Center just updated it. El Nino is likely to emerge. That's up to 80% now from May through July, and is expected to persist through the Northern Hemisphere winter going into next year. 96% chance of that extending from December to February of 2027. So you go on the next slide. These are the latest probabilities from CPC that was issued in May. On the left is the official NOAA ENSO probabilities for each 3-month period. So May, June, July, MJJ there in the bottom on the x-axis there. You can see that that's the 82% chance in the next several months, and that those probabilities don't really lower. They do continue to rise as we get into the late summer and the fall, and especially in the winter when ENSO has a larger impact. On the right is the strength probabilities, also issued in May. And the takeaway from that is we're focusing on the darker red. That is indicating a 1 in 3 chance of a strong to very strong El Nino from late November into January of next year. That seems to have increased compared to their April outlook as well. Go to the next slide. So El Nino varies from event to event. People have talked about one drought is not the same as a previous drought, or this drought is different in some ways from 07, 08. So El Nino is very much the same. It's not, one El Nino doesn't have the same impacts. It does vary. It depends on a lot of different atmospheric circulations as well across the mid-latitudes and the polar regions, and how that influences the overall pattern. El Nino usually favors a cooler and wetter winter for the Carolinas, Southeast, due to an active subtropical jet stream. But certainly there are outlier events. Summertime, the El Nino impacts are kind of subtle. Usually there's a reduction in Atlantic tropical cyclone activity, and that usually favors drier weather for the Southeast. But it's also often slightly warmer, so some of those signals can be kind of mixed there. I want to point out the official NOAA hurricane outlook is going to be taking place in a couple days, this Thursday, May 21st. So for those that would like to find out what the official forecast is, check out in a couple days. That's a free webinar for anyone that wants to go into that. All right, go to the next slide. And this is the last slide I have, just kind of showing, we talk about El Nino favoring reduced Atlantic activity. So why is that? So this is from climate.gov. Obviously, over the central and eastern tropical Pacific, we have warm and wet conditions, the above normal ocean temperatures favoring increased shower and storm activity across the eastern part of the tropics of the Pacific. And usually across the Pacific west of Baja, more hurricane activity, just less vertical wind shear there. However, as you get into the Atlantic, Caribbean, Gulf of Mexico, usually favors fewer hurricanes from a combination of factors: stronger vertical wind shear, stronger easterly trade winds, and also greater atmospheric stability. So all those kind of factors together to reduce the overall tropical cyclone activity. Now again, each El Nino is different in its own ways, and we'll just have to kind of see how everything evolves as we go forward. So that's all I have.
Thank you all so much for for everyone's participation in presentations. I know there was a lot of information on here, and I know we ran over. There was a lot of great information, and unfortunately, the Southeast is dealing with comprehensive impacts to the dry conditions, agriculture, forestry, water resources. We even saw some stuff about recreation in there as well. We do have a moment or two for questions if you want to put them in. I would like to also just quickly say, if you're interested, you can sign up for getting information for the Southeast webinars using this QR code. If you want to get information about the last drought status update for the Southeast that was done in mid-April, you can access that there. I'm sure we'll be doing a follow-up one here maybe within a month or two, depending how conditions go or if impacts intensify. But if you have any questions after the webinar, please feel free to reach out to me at elliot.wickham@noaa.gov. I'd be happy to answer your questions or put you in touch with partners if you have anything specific. I want to go I'll check the chat here to make sure I'm not missing anything. One question that did come up that needs to be answered was about Apalachicola Bay is reporting oyster predator levels in the bay and are already equivalent to the summers of 2008 and 2012 droughts. With the reservoirs in Zone 1, is it possible to increase or sustain flows to Apalachicola for a longer time to help the bay? Our partners from the Army Corps of Engineers had to drop off. What I can say now is that while they're currently in Zone 1, what Bree said is they're technically still operating in Zone 3 based off of where their inflows were. And so they're still operating under drought conditions. And so they're not going to make any changes to their conditions until the 1st of June, or at least that's when they're going to reevaluate where they're at. And so there won't be any updates on any increased flows or anything like that, to my understanding, until they get to the 1st of June when they reevaluate conditions. Let's see here. I don't see any other questions in the chat. I'll give it another moment, but again, thank you all for tuning in. Thank you so much to all our presenters for all this wonderful information. And hopefully we get sustained rainfall going forward, but we also don't want all of that at once, because then we're going to flip to the other side. We need the sustained rainfall over a period of time so that we don't have to deal with flooding as well. I don't see any chats coming through, so I will go ahead and close it out here. Thank you again to everybody. The recording for this will be coming out. And again, if you need anything, feel free to email me at elliot.wickham@noaa.gov. Thank you. Have a great one.